Great. I'm really enjoying this session. Our third paper is called Mixed Messages, the Limits of Automated Social Media Content Analysis. And I will hand over to Natasha, who will be telling you about this.
Thank you. Can you all hear me okay? Yes. All right. Let's fire this up. Okay, we've got a lot to cover, and it's not going to be as exciting as Bollywood, so if you need to take a stretch break, go ahead. Lunch is coming up soon. So quick housekeeping. Shout out to my colleagues, Emma Llanso and Anna Loup, who wrote this paper with me, and especially to all of the people who reviewed this report before we published it, many of whom are in this room. Thank you so much. The report is actually published on CDT's website, which is why we are not in the proceedings. So the reason we wanted to write this paper was to sort of push back on some of the magical algorithm thinking that seems to be informing the policy debates around the use of moderation of social media, use and moderation of social media content. So I'll show you some examples of what I mean by that. So last fall, UK Prime Minister Theresa May called for social media companies to identify and take down so-called terrorist content within 2 hours of it being posted. The UK Home Office also recently said that they have software that can automatically detect ISIS propaganda videos with 94% accuracy. However, they haven't released details, I don't think, about how this program is actually working. So is it just matching new videos to videos that it already knows are ISIS propaganda? How are they calculating this 99.99% success rate? And how would you choose which videos require human review? So on one hand, you have escalating calls by governments for social media companies to do quicker, more accurate moderation of content. And on the other hand, US agencies are looking to tap into social media data and analytics themselves for law enforcement and immigration purposes. So the Department of Homeland Security is currently seeking a contractor to automate parts of the so-called extreme vetting process, to use machine learning and social media data to make predictions such as who will be a positively contributing member of society and who intends to commit a criminal or terrorist act if they come into the country. So governments see both a problem and an opportunity with social media. On one hand, they want to control the spread of certain problematic content, and on the other hand, some want to harness that content for surveillance and law enforcement purposes. So my co-authors and I are not data scientists, but we suspected that these policymakers were putting too much blind faith in the capabilities of automated processes to discern some sort of meaning from social media content. So we looked at the natural language processing, or NLP research, and we found that, in fact, it does have real limits that make it problematic for making consequential decisions, like censoring people and making immigration decisions. But luckily, there are people who are doing great work in NLP, and the reason that I'm presenting here is that I think that those researchers can play a really important role in bringing some more information to these policy debates around the use of these tools. And so in the paper, we talk about 5 limitations, and we have recommendations both for policymakers and for researchers. But today, I'm going to focus on 3 areas that are sort of misunderstandings about the capabilities of NLP where I think researchers can do a lot to sort of inform this debate. But first I have to give a really quick, really oversimplified technical overview of, so what does it look like to use natural language processing when we're trying to moderate content or predict something about harm. So let's say we're trying to build a hate speech detector, which is a pretty common problem that researchers and industry are using NLP to try to solve. So we have to build a hate speech classifier. So we need to build a corpus of examples that the classifier will learn from. So let's say we compile a corpus of tweets. Typically, we're going to have human annotators label these tweets as either hate speech or not. And often they are crowdsourced workers. So then we're going to train the classifier on these examples to recognize new examples of hate speech and test the classifier on a set-aside portion of the tweets. So now that we have gotten that out of the way, the first weakness or area of misunderstanding I want to focus on is the false promise of one-size-fits-all or out-of-the-box NLP tools. There are many examples of tools that can be purchased and used out of the box on unlabeled data that promise to provide valuable insights from it. This has obvious economic appeal, particularly for smaller companies or for government agencies that don't have technical expertise in-house. But in order to be reliable, NLP tools need to be trained on domain-specific examples of text. So what does that mean? Well, the way people talk, the way people use language can vary significantly depending on the platform they're speaking on, who they are, their demographics, and what they're talking about. So the language of product reviews on Amazon looks a lot different from the language of political debates on Facebook. And NLP tools can only reliably classify text that is similar in domain or context to what they've been trained on. One area where out-of-the-box or standalone tools are common is in sentiment analysis, which involves classifying comments as positive, negative, or neutral. So there are a lot of sentiment analysis tools on the market that are advertised as things that you can use out of the box on any data because it's common in industry to want to use these tools to see what people think about your brand or your product. So Abbasi, Hassan, and Dar tested 20 of these standalone tools and 15 workbench tools, which are tools that require training on labeled examples. And they found that those workbench tools that were, they tested them across 5 different test sets on different topics of conversation. So for example, telecommunications, consumer retail products. And they found that on average, the workbench tools that were trained on labeled examples did significantly better than the standalone tools, 67 to 71% compared to about 56% average accuracy. Domain can also be problematic in hate speech detection. So hate speech may seem like it's pervasive on the internet, but in fact, compared to the total volume of content that's on platforms like Facebook and Twitter, hate speech is still a relatively small percentage of that content, which means that building a random sample of training data that represents enough hate speech to train a classifier is very difficult and very expensive. And so one workaround for this is to start with a pool that already represents more hate speech. So researchers have searched search terms or hashtags or gone to forums that they know are going to yield a higher percentage of hate speech. For example, going to a messiness forum on Reddit. But the problem with this is the resulting classifier is going to end up learning a particular subtype of hate speech disproportionately. So whether it be Islamophobic speech, anti-black racism, sexism, the language and especially the terms are going to vary across different subtypes of hate speech. So this suggests that the resulting classifiers may not be as good at detecting hate speech overall on a platform as they are at detecting a particular subtype of hate speech. So it's important that policymakers understand the domain limitations of different NLP tools, and researchers can help with that by being very clear about the domain limits and of the training corpus, or even testing the same tool across different domains and reporting the results. So the second issue I want to talk about is accuracy, and specifically putting accuracy rates in context and understanding their meaning. So in the NLP studies, accuracy is often a measure of how often the model output the same classification as the human annotators. But human annotations don't necessarily represent ground truth. It depends what we're trying to do. So if what we're doing is just trying to take down content that is offensive to people, then maybe it's okay that what a majority of people find offensive is our benchmark. But what's often expected of these tools is to make some kind of prediction about not just what's actually in the text, but the intent of the speaker. So the fact that a majority of people think that a tweet is terrorist propaganda doesn't mean that the speaker is actually a terrorist, and doesn't account for things like newsworthiness that might militate against taking something down. So if we want to know if NLP is accomplishing its goals, we often need to look beyond these measures of accuracy. The other thing about human annotations is that obviously they involve human bias. And although the standard is to have annotators reach some sort of threshold agreement, so only including examples where 50% or more of the annotators agreed that something was, for example, hate speech or not, that doesn't necessarily control for widely shared cultural bias about what is and isn't hate speech. Some studies are reporting accuracy rates above 80%, and these are impressive research contributions, but that's still low to be relying on these models for consequential decisions like censoring speakers and generating deportation leads. To put this in context, Facebook receives approximately 1 million notifications per day of content that allegedly violates its community guidelines. So even if you could predict with 99% accuracy which of those flagged comments actually violated the policy, you would still be wrong about 10,000 posts every day. So human review remains an essential part of the content moderation process. These reported error rates can be even less meaningful when we are using these tools to predict relatively rare events like extremist violence, or even hate speech, which is often less than 1% of all content. And as with any model, the accuracy can often be lower for speakers who are not in the majority. Actually, at the last FATML conference, Sulan Blodgett and Brendan O'Connor presented their great paper on racial disparity in NLP, and they tested popular NLP tools on tweets using slang or dialect that's common among African American Twitter users. And they found that across the board, the tools tended not to be able to classify those tweets as actually being in English. And one of the tools they reported actually classified these tweets as being in Danish with 99.9% confidence. So there are all kinds of language representation we need to worry about in training sets, not only representing other languages, but also dialects and non-standard usage. The final point I want to make is that language is messy, and researchers should not shy away from dealing with this messiness and talking about how they dealt with it. So NLP models can work well when we have clear definitions for classifying content, but the policy problems we're applying NLP to now don't tend to lend themselves to these neat definitions. One example is when we looked at the hate speech detection research. You don't need to read this, but these are just some of the definitions of hate speech that we came across. And you can take my word for it that these are all different. Not to mention this nonsense about positively contributing member of society. How would we look for that? This is not something that is anywhere in current law. the process of having humans label the training data can seem to smooth out some of this messiness, but saying that we're only going to train a model on tweets that have where a majority of people could agree that something was, for example, hate speech. The problem with that approach is that it's difficult for humans to agree on these squishy labels. And so throwing out examples that were difficult for people to agree on means the model is learning even less of this messiness and nuance that truly exists in speech. So Bjorn Ross and his colleagues achieved particularly low agreement in their hate speech study and concluded that perhaps this type of task shouldn't be a binary classification at all, but should be more detailed and involve more detailed and nuanced annotations. But there's also a lack of publications that actually describe in any detail how annotators were asked to label examples. So publishing more of that information would be a good first step toward all of us having a better understanding of the utility of various training sets. All of this is compounded by the fact that language is constantly evolving. So people have evaded filters by, for example, using triple parentheses to stand in for offensive words, or using the names of companies like Google and Facebook to stand in for racial slurs. And I'll just close with two very high-level conclusions. The first is that manual review remains essential in content moderation, and I said that before. And the second is that any attempt to use online speech to predict offline events or speaker intent should be approached with extreme skepticism. There's no real evidentiary basis that we can solve real social problems by focusing on what people are saying on social media. And NLP still makes many of its mistakes on things like sarcasm and jokes. So we should be really skeptical of how we are using this to think about, the connection between what people are saying online and what they really mean, or any real world consequences. Again, here's a link to the report. There's a lot more in the report, so I hope that if you're interested, you check it out. Thank you so much, and I will take questions now.
Hi.
Hi.
I have a little bit of a background in both selling to the federal government and then also working in the federal government trying to change the way we build products and also buy products. So my question is around, what are your methods, thoughts, suggestions, recommendations for getting stuff like this into a place where it actually does impact the DHS buying the types of tools that it might buy and getting that into their hands?
Yeah, so I'm working on that right now, and I hope that you can help me figure that out, because since you have the experience. So with the DHS example that I gave, there's a coalition of us who are working to, because this program isn't actually off the ground yet, to make sure that DHS doesn't end up buying some software that claims to make predictions about positively contributing members of society or future terrorists that obviously won't work and will be very discriminatory. And so, what we've been doing is meeting with Hill offices. We've been giving them questions that, oversight questions to ask. But, I am thinking about what are the sort of tools that we need to create so that there's some sort of uniform, better understanding and processes when agencies are looking to buy these types of tools, for them to be able to evaluate whether they actually do what they say they're going to do, and how they affect people across demographic groups. Yes.
Hi, thank you for the great talk. I had a question about the human content moderators, which I generally agree with you that we need some sort of human moderation in the mix, but there are people who have complained about psychological harms that they've received from doing the content review. So how do you think we go about reconciling the psychological harm with the need for this nuanced human intervention?
Yeah, I don't know. Content moderation is a really complicated issue, and I do think it's going to involve, or it does and needs to continue to involve some combination of automation and human review, but there is a labor problem in terms of staffing that moderation and dealing with the psychological effects, and I'm really glad that it's not my job to figure out the answer to that, because I don't have it. Thank you for the question.
Great. All right, everyone. Thank you.